Hi my dear students, Assalamu alaikum to all of you welcome physics class. Okay. In the last class we learned about speed. Okay. In the last class we learned about speed, uniform speed and non-uniform speed. Okay. Yes. Today we are going to study about uniform velocity and non-uniform velocity. From that all of you take page 82. All of you take page 82. The details of the journey of three cars is given here. Three cars is given here. Car A. What about car A? Car A covers equal distance in equal intervals of time. And a car travels along 5 meters along a straight line. Car travel along 5 meters along a straight line. Is it? Yes. And equal distance in equal interval of time, 5 meters along a straight line. Okay. Okay, that time equal intervals of time at 4 seconds, 8, 12, like that. 60 seconds here, 100, 200, 400. 300, 400, like that. I take approximate values. That means the equal distance in equal intervals of time. Then car B. Car B that also travel along straight line 500 meter. But the distance covered by the car unequal distance in equal intervals of time. Unequal distance in equal interval of time. 12 seconds, 16 seconds. But time but distance is different. Like that. Is it in car B? Then car C. Car C travels 500 meters along circular path. 500 meters. The car covers equal distance in equal intervals of time. Equal distance at 4 seconds, 100 meters, like that. I take approximate values but equal distance in equal interval of time. 8 seconds, 200. Is it? Yes. Okay. So from car A, equal time and equal distance. Here equal time but unequal distance. Here equal time and equal distance but it is travels along circular path. Like that a body has uniform velocity. Here which one have uniform velocity? Yes, car A, because uniform velocity if it covers equal displacement in the same direction in equal intervals of time. Equal displacement and same direction in equal intervals of time. So it's known as, this is uniform velocity. But these are not uniform velocity. These are known as non-uniform velocity. Why? If either speed or direction change. Here direction change, here speed change. So the velocity is non-uniform. Here uniform velocity, here non-uniform velocity. From this you have a table in your textbook. Based on this above information all of you complete the table. Car A, car B, car C. Yes. How to complete? Car A, car B, car C. Is it uniform velocity and it is non-uniform? Is it uniform velocity or non-uniform velocity? Car A. We know that car A is uniform velocity. Car A is uniform velocity. Why? Neither the magnitude nor the direction changes. Magnitude and direction not changes. So, car A is in uniform velocity. Next, car B. Is it uniform velocity or in non-uniform? Yes, it is non-uniform velocity. What is the reason? Direction does not change. Here direction does not change, but velocity changes. Here in car B, velocity changes because its displacement distance is changes. That's why velocity changes. Then car C. Then car C, is it in uniform velocity or non-uniform velocity? Yes, it is non-uniform velocity. What is the reason? Magnitude of velocity does not change. Here magnitude does not change, but direction change because it is in circular path. Car C in circular path, so its direction changes. That's why this is in non-uniform velocity. Got it? How to mark this uniform velocity and non-uniform velocity of this cars? Good. Okay. Then what are the examples of other examples of uniform velocity and non-uniform velocity? In uniform velocity, when light travels through a vacuum. Light travels through a vacuum, that's uniform velocity. Another lift, you know that? That also uniform velocity. What are the non-uniform velocity? Here given a train starting and moving off the station. That is non-uniform velocity, like that. Needle of clock. Yes, because that's in circular path. Then what is another? Yes, motion of a coconut falling from a coconut tree. Motion of a coconut falling from a coconut tree, that is also non-uniform velocity. Okay, next we are going to study about acceleration. In page 83, we can here details of the journey of car in a straight line are given. At 0 second 0, 5, at 5 second 5 meter per second, 10 second 10 meter per second, 50 second 10 meter per second, 20 second 6 meter per second, and 25 second 0 meter per second. Yes, this is the values here. From these values, we can complete the table 6.10. Complete the table 6.10. First, distance travelled by the car. Yes, distance travelled by the car. Then initial velocity. Initial velocity we can mark as u. Initial velocity mark as u. Then final velocity. Final velocity mark as v. Then change in velocity. Change in velocity means v minus u. That is final velocity minus initial velocity. Then time. T. Rate of change in velocity, that is a is equal to v minus u divided by t. Yes, v minus u divided by t. First, distance A to B. A to B. What is the initial velocity of A to B? From this data, okay, I will draw that data here. This is the journey of a car A to B, C, D, E, F. Okay. At A, 0 meter per second. At B, 5 second, 5 meter per second. At C, 10 second, 10 meter per second. And given D, 15 second, 10 meter per second. At E, 20 second, 6 meter per second. At F, 25 second, 0 meter per second. From this value, we can complete the table. At distance from A to B. Distance from A to B. What is the initial velocity here? Yes, we know that initial velocity here, that is u, is 0. A to B, u is 0. Then what is final velocity? 0 meter per second. Then final velocity? Yes, 5. A to B, final velocity 5. 0, 5. Then what is V minus U? 5 minus 0, that is 5. V minus U, 5 meter per second. 5 meter per second. From A to B, what is the time here? 5 minus 0, that is 5. 5 seconds. 5 seconds. The rate of change in velocity or acceleration. How to find out? V minus U divided by T. V minus U, what? 5. Then 5 by 5 what? 5 by 5. We get 1 meter per second square. Then next, what is second one? B to C. B to C. All of you look here. B to C. B to C, what is the initial velocity of B? Yes, 5. Initial velocity 5. And at C, initial velocity 5 meter per second. And what is the final velocity here? 10 meter per second. Then what is V minus U? 10 minus 5, that is 5 meter per second. Here, B to C, what is the time? 10 minus 5. 10 minus 5, that also 5 seconds. Then what is the acceleration here? 5 by 5. Because V minus U 5 T times 5 by 5, 1 meter per second square. The next, C to D. C to D. Look here, C to D. What is the initial velocity of C to D? 10 meter per second. 10 meter per second. What is the final velocity? 15 meter per second. 10 meter per second and final velocity also 10 meter per second. Here C to D. C to D, U and V are same, 10. Then what is V minus U? 10 minus 10, 0. What is time? 15 by 10, 5 seconds. But 0 by 5, 0. 0 by 5, 0. Then D to E. Then D to E. What is D to E? Yes, D to E, what is the U? U means initial velocity 10. 10 meter per second. What is final velocity? 6 meter per second. What is V minus U here? Here V minus U, 6 minus 10. 6 minus 10. 6 minus 10 means what? Yes, minus 4 meter per second. Here have negative sign because small number minus big number, we get negative number. 6 minus 10, minus 4. Minus 4 meter per second. And time here, yes, 20 minus 15, that also 5 seconds. Then how to get this? Minus 4 by 5. What is the answer? Minus 0.8 meter per second square. Here get negative value. Then E to F. Then E to F. E to F. What is the initial velocity and what is the final velocity? Initial velocity 6 meter per second. Final velocity 0. Then what is V minus U? 0 minus 6. Here also have negative value. Minus 6 meter per second. Minus 6 meter per second. Here also have time. 25 by 20, 25 minus 20, that is 5. The rate of change of velocity or acceleration. Minus 6 divided by 5 minus 1.2 meter per second square. Minus 1.2 meter per second square. All of you know how to get these values? Yes, because From this data, we can first write u, use the initial velocity, second v is the final velocity, v minus u, and t acceleration. How to find out acceleration from here? Acceleration is equal to v minus u divided by t. Acceleration is equal to v minus u divided by t. Okay, so here 5, v minus u get 5 and t 5, 5 by 5 1, here also 1, here 0, v minus u 0, so get 0 at c to d. Then d to e and e to f we get negative acceleration, because v minus u here minus 4, e to f minus 6, that's why we get negative acceleration here. From this, what do you know what is acceleration? From this we can understand that what is acceleration. Acceleration is the rate of change of velocity. Acceleration is the rate of change of velocity. That means how to find out the acceleration? The equation of acceleration is a is equal to v minus u divided by t. That is change in velocity divided by time. Change in velocity divided by time, that is a is equal to v minus u divided by time. Acceleration is a vector quantity. Then how you get a meter per second square here? Unit of acceleration get meter per second square here. We know that acceleration is equal to velocity, change in velocity divided by time. The unit of velocity is equal to meter per second. Unit of velocity meter per second, and unit of time is equal to second. Then meter per second, meter per second square. All of you must know the unit of acceleration also, that is meter per second square. So now to some examples. Situations of acceleration occurs. The motion of coconut falling from the coconut tree, moving ball, like that there are some situations in acceleration. Next there is a question. To how to find out acceleration. In your textbook, page 84, a food packet dropped from a helicopter reaches the ground in 5 seconds. The velocity with which it hits the ground is 50 meters per second. What is the acceleration? We know that acceleration is equal to change in velocity divided by time. Time, that is v minus u divided by t. What is v minus u here? V here, yes, v 50. Ground is 50 meters per second. So acceleration velocity 50 or final velocity 50. What is initial velocity? Because at u is equal to dropped from helicopter reaches the ground. So u is equal to 0. Put u is equal to 0. What is time here? 5 seconds. 50 by 5? Yes. 10 meter per second square. Meter per second square. Yes. An acceleration produced in object falling freely due to the acceleration of the place. Okay. As gravitation, letter G. That value is 9.8. Next, we are going to study about retardation. It is retardation. Yes, you know that here at D to E and from E to F, we can get this acceleration negative values. We can get acceleration negative values from D to E and from E to F. Yes, this negative acceleration is known as retardation. This negative acceleration with the velocity begins to decreases. Here velocity decreases. That's why we get negative acceleration. So this is known as retardation or negative acceleration. Yes, your textbook have some questions. Find whether acceleration is positive or negative. First, a ball rolling on a level ground. A ball rolling on a level ground. Here decreases, velocity decreases, so negative acceleration. Then second, a train starting from the station. The train starting from the station, yes, it increases, velocity increases, that's why it's positive. Next, third, the motion of a stone thrown up. Thrown up, it decreases, so negative, and comes down. That here velocity increases and positive acceleration. Yes, in the time of speed, we said that the excess speed of vehicles may cause the accidents. Excess speed of vehicles cause the accidents. Okay, we can have to minimize the death of accidents. We obey the traffic rules. We always obey the traffic rules and signs put up. Okay, there are some signs seen in roadside. What are they? Speed thrills but kills. Don't mix, drink with drive. Better late than never. Wear helmets while driving motorcycle. These are some signals on roadsides. All of you try to draw like that. Okay. Next, if only this excess speed is reason for accidents, not only, but also have what? Carelessness of pedestrians also a reason for accidents. So, what are the precautions should take for pedestrians? Yes, what are they? Yes, walk along footpath only. Walk along footpath only. Then next, walk only along right side of the road. Walk only along right side of the road. Then cross road only through zebra line. Cross road only through zebra line. While walking at night or evening, not use dark dresses or dark color dresses. Not use dark color dresses while walking at evening or night. Don't walk with the groups. These are the precautions of pedestrians. Okay. Then next, there are some permitted speed on roads of Kerala. Also given the table. Permitted speeds of roads on Kerala. What are the speed limit here? Vehicle, motor car, motorcycle, auto rickshaw, bus. In the premises of educational institutions. In educational institution, motor car 30. Use only the speed at kilometer per hour. At kilometer per hour, use 30. Motorcycle and auto rickshaw, bus all have use only speed in 30 km per hour in the premises of educational institutions. Very less speed. That means use only very less speed. By roads, a motorcycle 45 km per hour, motorcycle 45, auto rickshaw 35, bus 40, like that. There are so many speeds here. Okay, so many permissible speeds on road of Kerala. Next, in municipal corporation sites, what are they? Use 50 km per hour, motor car and motorcycle. But auto rickshaw 30, bus only with the speed 40 km per hour. The national highways. National highways, motor car can move with the speed 85 km per hour. But motorcycle 60 km per hour. Auto rickshaw 50, bus 65. These are the permissible speeds of these vehicles of roads of Kerala. Next is state highways. State highway, motor car 80, motorcycle 50 and auto rickshaw also 50 km per hour, bus 65. Four line roads. road use maximum speeds. That is, motor car use the speed with 90 km per hour, motorcycle 70 km per hour, and auto rickshaw 50, and also bus 70 km per hour. Yes, these are the permitted speed of road of Kerala. Okay. Yes, next now we finish our chapter. We finish our second chapter. Yes, what we learn in this second chapter? Yes, we learn this here. What is the chapter name? Motion. We learn in this chapter distance and displacement. Distance and displacement, and vector quantity, scalar quantity. Then speed, velocity. Speed is the distance travelled in a unit time. We know that speed is the distance travelled in a unit time. What is the equation of speed? Speed is equal to distance divided by time. Then velocity is the displacement travelled in a unit time. Velocity is the displacement travelled in a unit time. What is the equation of velocity? Velocity is equal to displacement divided by time. Okay. Then you also know the units of that meter per second. Then we learn about uniform speed and non-uniform speed, uniform velocity and non-uniform velocity. Now today we learn about acceleration. What is acceleration? That is rate of change in velocity. Rate of change in velocity. How to find out acceleration? Acceleration find out change in velocity divided by time. Change in velocity divided by time. So A is equal to V minus U divided by T. Then its units meter per second square. Now also we learn about retardation. Negative acceleration is retardation. Then we learn about some situation about this acceleration, non-uniform velocity, velocity, all about that. All of you must study everything about this chapter. Okay. Okay, let's wind up today's class. Okay, thank you.